Hello everyone, this is Siddharth here. Today we'll be discussing this week's contest second question, longest subarray with maximum bitwise end. We are given a nums array and we are to return the length of the longest such subarray in which we have the maximum possible bitwise end. So first of all, let's understand what can be the condition under which we can have a maximum bitwise end. So let's take these two numbers 9 and 11, and these are the binary representations of 9 and 11. So we are aware that 11 is the maximum value among the two. We know 1 and 1 make 1, 1 and 0 makes 0, 0 zeros make zeros, and 1 and 1 make 1. So this will equate to 9. So we see that if we have two numbers and we have a bitwise end among them, then what we'll get is a number that is at the very least equal, or otherwise it just has to be less than the given maximum number among the two. So let's take another example. If I were to have, let's say, 4 and 6 as my another number, so 6 will be written as this, and if I were to perform bitwise AND among these two numbers, I know that 6 is the maximum value among these two, so I know 0 and 0 make 0, and 1 and 0 also make 0, and 1 and 1 always make 1 in bitwise AND. So this equates to 4 yet again. So I see that if I were to take bitwise AND of two numbers, then my resultant answer will always be lesser than or equal to my maximum value. So if I am given an array like this one, so if I am to return the length of such subarray which gives out the maximum bitwise end, so what I know is that my bitwise end, if I were to take bitwise end of all of these numbers, so it will always be less than 3, that I'm aware, less than or equal to 3. So now let's think about the case where I can maximize my bitwise end. So if I were to do a bitwise end between 3 and 3, so what I'll get is, so let's write 3 in its binary representation. You'll have something like this, and yet again 3. So if I were to perform bitwise end here, then I'll have 1 and 1 goes to give a 1, and 1 yet again. So if I am to perform a bitwise end between the same numbers, then that will give me the same number. Otherwise it will always be a number which is less than my given number. So the intuition is that I need to form a subarray which consists of all of my maximum elements in a given array. In this array I can form a subarray of these two elements. So my answer would be the length of this very subarray, which will be 2. In another case, I can also have a subarray like so. In this, I need to check what's my maximum element. I know 9 is my maximum element, and if I were to bitwise AND it with itself, then I'll have 9 only. So I know this is my maximum bitwise AND, but I need to form a subarray. I need to find a subarray which has the maximum length. So I need to iterate through this very array, and I need to see So if I go through my array, I know that my maximum element is 9. So what I need to do is I need to iterate through my array, and I need to check if this very element, the element that my pointer is pointing to, is 9 or not. If it's not 9, then I'll just move on. Otherwise, I'll have a maximum length variable, which is currently 0, and a resultant, which is also currently 0. I'll see this is not equals to 9, so I'll move forward. I'll see this is pointing to 4, this is also not 9. Now I'll come towards a position which is pointing towards 9, which has the value 9. So now I'll see that this is equal to my maximum value 9. So I'll increment my length to 1, and I'll also update my resultant. Now as soon as I move forward, I'll check if this is my maximum element or not. Since it is not, what I'll do is I'll yet again make my maximum length to be 0, because right now my maximum length is 0, but I know my resultant is already storing my actual maximum length of the subarray. Now I'll get to my next variable, which is 9, which is equals to my maximum value element. So I'll increment my maximum length right now currently to 1, and then again, if I am to come across the last element, and I'll check if this again is equals to 9, then I'll increment again by 1. So I see that my maximum length is greater than my resultant, so I'll update my resultant to 2, and I'll return 2. So 2 will be my answer in this one. So now let's code it up. First of all, we need to find our maximum element. I can do that by using maximum element stl in C++. It has a time complexity of order of n, so I could have used a for loop either way, but since it has a small syntax, that's why I will be using max element. And what I need to do now is I need to have two variables, maximum current length, that would be 0, and a resultant, that would be 0 yet again. I'll just iterate through my array, and I'll check if my current element is equals to my maximum element. If that's the case, then I'll increment my current maximum length by 1, and I'll also be updating my resultant. My resultant would be the maximum value of my current resultant value and my maximum length. If that's not the case, if my pointer is not pointing towards a place which holds my maximum value, then I'll just reinitialize maximum length to 0, and I'll just return result. So let's see if this is working. So it's running perfectly fine. Now let's submit it, and it's working perfectly fine. So thanks for watching, guys. Like and subscribe if you like the content, and if I am doing anything wrong, or if you'd like to give any suggestions, then I'd be happy to hear from you guys. So I'll catch you in the next one.